Inside this rocket is the rover that could find life on Mars, if it lands.
We've got to go from thousands of miles an hour to 0 and not do a bug on a windshield.
The new rover is called Perseverance.
Perseverance is the most sophisticated piece of robotic hardware ever launched off of the Earth.
It will search Mars for signs of life, while Smithsonian scientists roam the Earth for reference.
The search for life is one of the biggest questions humans have.
Previous rovers set the stage. Now Perseverance could reset our view of the universe.
We're going to get one shot at this.
Meet the rocket, the rover, and the helicopter that could change how we explore Mars and beyond. It's all riding on Perseverance. February 18th, 2021. The sky is orange. Under bright sunshine, it's minus 80 degrees Fahrenheit. The 8-year-old Curiosity rover dutifully carries on. Otherwise, Mars is quiet as a desert. But here comes the new kid on the block. After 7 months of smooth sailing through space, the bumpy ride begins.
As the spacecraft encounters the upper part of the atmosphere, it will heat up. Once it slows down enough, then the heat shield will come off, and we will deploy a parachute.
But we're still literally hurtling towards the surface, even after being on that parachute for a ways. Remember, this is a car-sized object that weighs almost a ton.
No human steers it, but it has just 7 minutes to thread the needle, or this next Martian explorer will crash and burn. Meet Perseverance, our newest Mars rover.
It's a huge beast of a machine, and it is chock full of scientific instruments that are going to explore the surface of Mars.
At NASA's Jet Propulsion Laboratory in California, Perseverance comes together in a clean room. If it's going to find life, it can't bring any life with it.
It's really important to make sure that we send a clean rover to Mars, because if we do find something on Mars, we have to make sure it's something that actually came from Mars and not something that hitched a ride.
They're building the most complex rover ever, including 23 different cameras. Mastcam Z mimics human eyesight by capturing stereo panoramas. A chemistry cam on the robotic arm can zero in on the tiniest fragment. And for the first time ever, video cameras will record the rover's descent and landing from 4 angles.
So, with Perseverance, for the first time, we effectively have the opportunity to make movies.
Some of these cameras reach 5K resolution. That will beat the pixels off of this.
Prior to 1965, the best views of Mars came from Earth-based telescopes. We really had no idea of what the detailed surface of Mars looked like.
In the absence of data, humans dreamed. We had centuries to conjure up ideas about Mars. Some scientific, some silly.
The popular view of Mars is that it did have life. There were aliens on it. You know, you have this entire sci-fi industry built upon that.
You speak wisely. I will go.
Nothing said Martian fantasy quite like Little Green Men.
I know. I don't think you'll be causing any more trouble.
Creative minds careened out of control. Until July 14th, 1965. Earthlings in California anxiously await a signal from their latest attempt to reach Mars.
2815.
The first two spacecraft failed. But Mariner 4 has a shot.
It was intended to take a few pictures of the surface as it flew by.
After a 7-month journey, Mariner 4 has less than 30 minutes to get the first close-ups of Mars.
The idea that you're going to see something for the very first time, if it works, is not only cause for tremendous excitement, but also tremendous trepidation. Will it work?
Images come in as data, taking 6 hours per picture. Finally, the printer comes to life. But Mars looks dead.
The initial reaction was, oh my gosh, it looks like the moon.
It was just this sort of dry, desolate, cratered surface. And I think that kind of punched a hole in the whole, romantic idea that there were Martians.
Mariner 4 snaps just 22 photos as it blows by Mars. But they rock our little corner of the cosmos.
That was an enormous surprise. And the beginning of our understanding that Mars is not the Mars of science fiction, but I think as a geologist, it's an even better place with all of these amazing things to look at.
With each mission, Mars comes into better focus. Mariner 6 takes 75 photos. Mariner 7 snaps 126. Then, our first orbiter, Mariner 9, circles Mars for nearly a year and takes more than 7,000 shots.
Mars was sort of unveiled globally for the first time to human eyes.
Now we see more than just craters. We see canyons and what look like dry riverbeds.
There were clearly branching systems of channels that were merging in a downhill direction. And of course, the most likely and logical origin for those was by running water.
Mariner 9 doesn't reveal when or why the water disappeared, but it jolts us toward a new theory. Maybe Mars isn't like the moon. Maybe it used to be more like Earth. Smithsonian scientist Ross Irwin studies how water can shape a planet and possibly spark life.
About 3.5 billion years ago, Mars had many rivers on its surface, which were about this size, and carved valleys about the size of the one behind me. When the Mariner 9 spacecraft arrived at Mars, it was a surprise to see these river valleys all over the place.
Subsequent missions revealed other Earth-like features.
In some cases, we have alluvial fans, where erosion of a mountain front has deposited sediment in a fan out across the floor of a basin. And then we also have deltas. And just like river deltas that you see here on the Earth, these river deltas on Mars represent deposits of sediment out into a standing water. All of these eroded river valleys and sedimentary deposits were compelling evidence of flowing water on the surface of Mars, but it left a lot of unanswered questions. How long was the water there? Were these environments really favorable for the origin and persistence of life?
If ancient Mars had surface water long enough, it may have supported life and left evidence, just like on Earth.
This type of rock is very good for preserving evidence of past habitability. So it's not just indications that this environment may have been suitable for life, but it's also very good at preserving evidence left behind by life itself. Obviously on Mars, we're not looking for fossils, but we're looking for indications of whether there was bacteria on the surface of Mars during these wetter periods early in its history.
The only way to look that closely at Mars was to get on the ground. Mariner 4 did a drive-by. Mariner 9 kept circling around the block. Then Viking opened the door.
The anticipation for these missions was very high. These landers were going to soft land on the surface and actually look for evidence of life in the surface materials of Mars.
In 1976, Viking skids into the Martian atmosphere. It will either make history or crash violently. Building Perseverance to operate successfully on Mars is one challenge. Getting it to Mars is another. About every 2 years, the orbits of Earth and Mars put them in the same general neighborhood, but still millions of miles apart.
Mars is really far away, and getting the spacecraft there to a specific point is something that requires incredible time and attention to detail to make sure it happens correctly.
We did it incorrectly plenty of times.
In the very early days, we had mishaps on the launch pad. We had spacecraft fail to achieve orbit. We've had spacecraft hard impact on the surface. We miscalculated trajectories. We've had spacecraft that have had various hardware problems.
The last I heard there was that there was some funny business in the first 10 picture recording.
Getting to Mars is very, very hard.
Enter Viking, America's first attempt to land on Mars.
With Viking, there was very much of an element of a mission into the unknown.
NASA launches 2 Viking landers, hoping that at least one lands safely.
A huge amount is at stake. If you don't land safely, you don't get any science.
On July 20th, 1976, Viking 1 begins the landing sequence. It's too far away to control in real time. Viking is on its own. Famed astronomer Carl Sagan joins the mission team for the nervous moment. It's his first taste of the 7 minutes of terror.
There's this period of time that the spacecraft has to go through on its own to land on the surface safely.
That process takes about 7 minutes from the time it hits the top of Mars's atmosphere until wheels down on the surface. So we call that the 7 minutes of terror.
366 feet,
73 feet per second.
come on. ACS is close to vertical. Nav is green for touchdown.
Green for touchdown.
Finally, Viking 1 signals from the surface.
8 feet per second. Touchdown, we have touchdown.
Fantastic. 16 kilobits confirmed.
Oh my gosh. I think landing on Mars for the first time, I mean, it's just the most thrilling and exciting thing that you could imagine. I mean, landing on another planet and then having it open up and get your first image of a place that no human has ever seen.
July 20th, I turned on the TV and there was a picture of Mars from the surface. And it didn't look at all like what I would have guessed.
It looked like being in the desert southwest of the US. People could really relate to what they were seeing on the surface of Mars, I think for the very first time, because it was sort of like you were standing there.
Viking 2 lands a few months later. Neither lander finds existing life or standing water, but they begin a new era of space exploration.
We had landed on another planet, and that view will be forever in the textbooks.
The landers send back mountains of data, but they can't move.
They were fixed in one place on the surface. And there's always this sort of, what if we could just get to that rock over there?
Viking was groundbreaking, but it wasn't pathfinding.
And so I think that there's this natural progression to want to build mobility in the form of a rover into a subsequent mission that allows us to answer those questions.
20 years after the Viking missions, NASA embarks on a remarkable test drive.
So Sojourner was a very little rover. It was basically a microwave on wheels, if you think about something along a sort of size comparison.
It's named after civil and women's rights pioneer, Sojourner Truth, and it hopes to pioneer a new way to explore Mars.
It was primarily designed to be a demonstration that we could send a rover to another planet and have it operate successfully.
It's tucked inside a lander called Pathfinder,
100% green board.
and both rocket off to try to make history.
Main engine start. 1, 0, and liftoff of the Delta rocket with Mars Pathfinder.
Lander separation.
After landing and waking up, the spacecraft rolls out the first Martian rover.
Data. We have imaging data. Yes.
Even though it never ventures more than 40 feet from the lander, Sojourner makes the first tracks on Mars in 1997.
This is a game changer. Sojourner was kind of a turning point in Mars exploration because until that point, I hadn't personally fully appreciated what mobility could get for you.
Mobility is now the main focus. The new rover, Perseverance, practices her moves in what NASA calls the Mars Yard.
So we're here in the Mars Yard, and this is where our rovers practice driving over rocky terrain to make sure that we can get the best science possible on Mars and go to the most exciting places we can get to with the rover.
Each wheel has an independent motor and cleats for traction in the fine Martian sand. Legs are made of titanium, the same lightweight metal used in the best bicycles. Perseverance has to be strong and nimble if it's going to break new ground.
Often the most exciting geology outcrops that we want to study on Mars are often the most challenging to go to.
But it will not go fast. Top speed is less than 0.1 miles per hour. Interplanetary driving is a cautious business.
We're not talking about Daytona Speedway in terms of their moving around.
But what it lacks in speed, it has in scientific bling.
Perseverance is the most sophisticated piece of robotic hardware ever launched off of the Earth.
It has a 7-foot-long robotic arm to reach out and analyze the terrain. Lasers to see different wavelengths. Spectrometers to identify different compounds. It's a weather station, rockhound, and chemistry lab. All of it is designed to finally answer humanity's biggest question.
Are we unique in the universe? Perseverance is the first rover that really has the capability to get in and maybe help answer that question of whether there was ever life on Mars.
The search began with Viking, continued with Pathfinder and Sojourner. But bigger could be better. NASA starts work on twin rovers that dwarf Sojourner. Spirit and opportunity are a bold gamble. The new Mars rover Perseverance is in final assembly. Scientists can't wait to unleash it on the Martian surface.
My job is to oversee the science that the rover will do once it gets to the surface of Mars.
To get that science, mission planners hope it rolls for at least 2 Earth years and covers at least 12 miles. By contrast, our 20th century Martian explorers didn't explore very far. Sojourner didn't venture more than 15 yards from the landing spot. It's as if a Martian spacecraft landed in your backyard and only got as far as the fence. But in 2004, twin rovers take off.
So the Mars Exploration Rover Spirit and Opportunity really became that next step. We wanted to follow the water. We wanted to understand the role of water in shaping the landscape of Mars.
Spirit and Opportunity visit ancient riverbeds for the first close-up look at what water left behind. This time with hands-on tools.
These guys are about the size of a golf cart at this point, and so they're bigger. They're built as sort of field geologists, robotic field geologists on Mars.
Both rovers roll for miles, and the alien landscape starts looking familiar.
And we started seeing rocks that had ripple marks formed in them. Ripple marks, much like you might see in a riverbed where the water is flowing and transporting sand across the surface. You know, you can walk out your door and go to the local pond and see those same kinds of features.
The mission rolls beyond expectations and seems to have a bit of luck. When a wheel fails, Spirit accidentally scrapes up a layer of the red sand, revealing white.
So this bright white material that turns out to be almost pure silica tells us that it was probably precipitated from relatively hot water in a volcanic area.
Then Spirit stumbles upon another wild discovery. It beams home a series of images that could pass for Oklahoma. Dust devils, direct evidence of Martian wind. Then a Mars orbiter captures a dust devil rising a half-mile high, casting a shadow across the landscape. We know that on Earth, wind can be a shapeshifter. Smithsonian's Mariah Baker is an expert at recognizing its handiwork.
When you go to a desert or a beach like this, you can see that wind is constantly sculpting the landscape. When wind blows over a sandy surface, it can cause ripples to form, or dunes like these. On Mars, wind does exactly the same thing. In fact, it's been the dominant geologic force for billions of years since all the water dried up. Researchers like me can go to some of the most Mars-like places on Earth, like the Great Sand Dunes in Colorado and the Atacama Desert in Chile, to understand how surface features form on Mars.
But at some point, the similarities break down and the mysteries begin.
So in this dune, we can see what are known as impact ripples, which are the smallest surface features formed by wind. The smallest impact ripples that we see are formed in fine sand, but larger coarse sand forms these larger wavelength ripples. And when we arrived at Mars and we saw that these large ripples were also forming in just fine material, we realized that we didn't quite understand how they form entirely.
This is where Mars gets alien.
On Mars, we've got about a third of the gravity that we have here on Earth, which makes sand a little bit easier to move. However, we also have an atmosphere that's about 100 times less dense than the atmosphere here on Earth, which means that a 40-mile-per-hour wind might feel like just a breeze on our skin. And so we need much higher wind speeds to actually move sand on the surface.
But somehow, Martian winds can still whip the entire planet into a frenzy. Every year, Mars throws a few dust storms that last for weeks, but stay local. On occasion, one of them goes global.
When you have these occasional global dust storms, it can basically kick up dust into the entire atmosphere. It completely obscures the surface.
In 2018, the sharp features of Mars disappear in just a few months as a thick red cloud envelops the planet. The rover Opportunity is now almost 15 years old and has driven more than 28 miles. But a big storm is coming. Looking down, it sees dust accumulating on its solar panels. Looking up, it sees less and less.
And suddenly, the sky literally darkens over the course of a period of just a few short days. And the last image we have, looking towards the sun from Opportunity, effectively shows us in being in darkness.
The dust storm blocked out all sunlight from reaching the solar panels.
14, MER project manager. 14.
For 8 months, Opportunity's mission team sends ping after ping to try to wake up the teenage rover.
MER 1, spacecraft ID 253.
It never did power on again to call home.
Finally, NASA concedes.
And this is Station 14 on behalf of the network. It's a sad day for all of us.
MER project off the net. Thank you.
Because Opportunity was operating for 14 and a half years, people got very attached to the rover. And I can tell you that the people who were on those conference calls when we decided to end the mission were very sad.
Opportunity broke the mold for rover longevity. Perseverance is designed to be even stronger.
The first thing the rover has to survive, of course, is all the testing we do to it.
They run Perseverance through everything Mars could throw at it. Severe temperature swings, down to 200 below zero Fahrenheit. Blowing dust that could grind gears and blind cameras, but at least not cut power.
Perseverance is nuclear powered. We don't have to worry about dust storms.
It's called radioisotope power, essentially a nuclear battery. It converts the heat from the decay of plutonium into electricity. It could power Perseverance for years, if it survives the journey.
You design a rover for the sort of worst-case scenario. The worst-case shaking on launch. The worst-case hard landing. All have to be survived.
If Perseverance lands safely, it will see more than what's on the surface of Mars. It will take a peek underground at layers of history. On Earth, we see these layers at the most unlikely places.
When we do geology on the Earth, we often get fortunate enough to have a road cut like this from building a highway. And that road cut allows us to see the layers that have built up over time. Now, in a lot of cases on Mars, we're not going to be able to get some kind of cross-cut through the terrain like this. And what we have to do is use a remote sensing instrument called ground-penetrating radar. I work on an instrument called SHARAD, the shallow radar, on the Mars Reconnaissance Orbiter. SHARAD transmits signals, and that pulse will travel down through a layer like this. And each time that signal bounces back to us, we build up a cross-section, just like you see in the road cut here, in order to tell the geologic history of that area. They might be differences between sand layers and ice in the polar caps. But there's no substitute for being able to look in greater detail at what's right below your feet. The Perseverance rover will carry an instrument called RIMFAX, which will measure the subsurface layers beneath the rover down to a shallower depth than SHARAD, perhaps 10 meters, but with much finer detail. Now, someday, astronauts may be able to simply walk up to an area like this on Mars and make observations of the geologic history through the layering. But for the time being, instruments like SHARAD and RIMFAX are invaluable.
Perseverance is the first rover that can see underground. But it also carries something that could see over the horizon. At NASA's Jet Propulsion Laboratory in California, Perseverance has passed all of its flight tests. It's a month away from leaving home. It's built on the legacy of the rover that came just before it.
After the Spirit and Opportunity Mars exploration rovers, Curiosity became sort of the big sister on the block.
In 2012, Curiosity became the next rover in line for Mars. It's a major upgrade.
So it's about the size of a small SUV. In terms of its complexity and its size, it's just far beyond what we've done before.
Thank you for joining us.
All around the country, Curiosity sparks Mars mania. On landing day, Curiosity creates a buzz in New York City. At NASA, it creates a roar.
Touchdown confirmed. Proceed on Mars.
The biggest rover yet is safely on Mars.
Curiosity will take us.
It lands inside a fascinating landscape.
Gale Crater, I think, really is the place on Mars where you feel like you are on Earth.
There's evidence that Curiosity has collected that there was a liquid water lake inside this crater.
If you had been standing there, you would have been knee-deep in running water, and it would have been drinkable. I mean, you could take a cup and scoop it and drink it.
Curiosity drills into this ancient lake bed, finding thick layers of sediment that took thousands of years to build up.
For me, that was a real aha moment, because suddenly here I was staring in the face sediments that were very much like the sediments that were being deposited in the lake where I grew up in northern New York. And I was kind of dragged kicking and screaming into this idea that, by God, there was an ancient lake on Mars, and it was there for a good long time.
We now think water flowed on the surface for up to 1 billion years, but dissipated about 3 billion years ago.
The reason that the water became less stable on the surface is that the atmosphere changed and became very thin. Eventually, it became very dry and cold.
Perseverance will look at what water left behind, especially in craters.
Perseverance is landing in a place called Jezero Crater, where we see, because of an inlet channel and an outlet channel, that water once filled that up and overflowed. Perseverance is going to go and evaluate those sediments and those rocks, seeking signs of life.
The search begins with the rover's amazing arm.
So I would say the robotic arm is incredibly important for the mission because it has everything on its hand. And in fact, as I'm talking to you, you can see me moving my arm because it is so intuitive also. You're thinking about an arm just like yours, an arm where the fingers are the instruments, and you immediately can picture exactly what you will do if you were a geologist standing on the surface of Mars. Bring it down, put it here, let me see it.
At the end of the arm is a whole new suite of instruments that will look for traces of past life.
The robotic arm also has a drill in it, which is the actual unit that will collect the sample.
A drill on a rover is old news, but the fate of the sample could be big news.
Perseverance is going to collect and cache samples for possible return to Earth at some time in the future.
This rover will begin the most ambitious robotic space handoff ever attempted.
Perseverance will drill down and collect samples and put them in an area where a second rover can come in the future and pick them up. They'll be put inside a small rocket that will be launched up into orbit where they'll be captured and eventually return to Earth at some time in the future.
If Perseverance finds evidence of life, we'll need the sample on Earth to confirm it. Within a decade, we could be holding the first evidence of alien life in our hands.
The kind of holy grail is sample return, and Perseverance is the first step along that path.
Packed inside Perseverance is another space first. It looks like a spider learning to fly. But it's the first interplanetary helicopter.
Ingenuity, which is the helicopter that we're sending to ride along with Perseverance rover, is designed as a technology demonstration to, for the very first time, show that we can operate a powered flight aerial vehicle on the surface of Mars.
NASA creates a chamber simulating the atmosphere of Mars, where liftoff will be 100 times harder than on Earth.
With the atmosphere so thin, there's very little material for the blades to push against. So it's very light, and the blades are very large in order to get enough lift to be able to lift off the ground.
The copter passes the test on Earth. On Mars, it will have to fly solo because radio signals take an average of 15 minutes to travel between Earth and Mars.
It has to be done completely remotely. You have to be doing it without any real sort of real-time joystick control of where this thing is going to go.
If it works, Ingenuity could scout ahead for Perseverance, take detailed photos, and transmit them back to the rover for a sneak peek of where it might go. All while flying into the history books as the first powered flight of an aircraft on another planet. But it has to get off this planet first. The first step to Mars is a cross-country trip from California to Florida. 16 semis truck in pieces of the capsule that will carry Perseverance to Mars.
Those can all be sent separately, but the rover itself, fully assembled, was sent on a large airplane to Cape Kennedy.
At the launch site in Florida, they tuck Perseverance into the capsule, cradle it into the top stage of the rocket, and worry.
You're in a situation where you've got years and years of work wrapped up, folded, origami style almost, on the top of a giant bomb. And this thing goes bang and flies off into the distance. And it does so in a real hurry. And so there's a lot of personal fear that what happens if something goes wrong?
Launch day awaits. Just as the new Mars rover prepares to launch off the Earth, Earth suffers a devastating blow.
The rover is perfectly named as Perseverance because getting this rover to the launch pad occurred during a global pandemic. It's hard enough to get a rover built on time and with no mistakes in it, and you layer on a global pandemic, that's an extreme amount of stress and, pressure.
If something delays the launch, Mars won't line up this closely to the Earth for another 2 years.
We're going to get one shot at this.
Perseverance will ride on an Atlas V rocket. The boosters come from Alabama. The payload adapter comes from Texas. And the physics come from experience. It's not easy to hit a moving target at a cosmic distance.
The navigation people are trying to do this 100 million mile hole-in-one. The spacecraft is actually put to a place where Mars is going to be. So think about a quarterback throwing a long bomb downfield, even though the receiver is still 20, 30 yards away from where he's going to catch the ball, and knowing that the two are going to come together at that last second at just the right time.
What a beautiful morning here on the Space Coast. Welcome, everyone. Behind us, the star of the show.
After years of work, the moments before launch are like a vacuum.
Currently working, no issues on the Ranger or the launch vehicle. Appears to be ready to proceed.
They have a lot of their lives invested in these things. It's as if your child is leaving home. That is literally what is happening. It's just, in this case, the child is a robot that is going to another planet.
Go Atlas.
Go Centaur.
Go Mars 2020.
Engine ignition. 2, 1, 0. Release and liftoff.
Powered by 4 boosters, it leaps off the pad.
The perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
Barely 30 seconds in, it breaks the sound barrier.
And Mach 1 Atlas V is now supersonic.
90 miles up, the solid rocket boosters peel off.
And we have a good indication of SRB jettison of all 4 SRBs.
Just 4.5 minutes in, the rocket drops back.
And we have good indication of Atlas Centaur separation.
Perseverance puts Earth in the rear-view mirror.
To have watched this rover launch to Mars was an incredible feat.
Successful separation of Mars 2020 with the Perseverance rover.
There we go. Awesome.
Now it enters the cruise phase, 6 months of silent sailing that will end with a terrifying 7-minute leap of faith.
When the spacecraft gets to Mars, it's literally going thousands of miles an hour. And so we've got to go from thousands of miles an hour to 0 and not do a bug on a windshield.
The heavier the spacecraft, the harder it is to slow it down. Viking was light enough to land with a parachute and some retro rockets. The heavier Spirit and Opportunity rovers needed giant balloons to cushion their impact. Now, 1-ton Perseverance will take a far trickier path.
As the spacecraft encounters the upper part of the atmosphere, it will heat up. Once it slows down enough, then the heat shield will come off. Once we've slowed down enough on the parachute, then the rover will separate from the back shell. That's when the engines on the descent stage will actually ignite and slow us down to eventually hovering over the surface. The rover itself will actually be gently lowered, spooled on cables. Once the wheels touch the ground, the cables are cut and the descent stage flies away. And then we have a rover on the surface of Mars.
If it lands safely, Perseverance could provide the first evidence that Mars supported life. But it will also ask, could Mars support us?
It can be minus 200 degrees Fahrenheit. It can be windy. It can be dusty. So it's a pretty tough place to exist.
One experiment on Perseverance called MOXIE could set the stage for future astronauts.
The MOXIE instrument is going to take carbon dioxide out of Mars's atmosphere, strip out oxygen from those carbon dioxide molecules. So the instrument will be generating oxygen with the materials already present on Mars.
Maybe future astronauts could breathe oxygen mined from the atmosphere. Maybe they could draw water from the ice underground and grow food inside their Mars base. Perseverance is blazing the trail for it all.
I think all of us hope eventually humans will get there. Well, that's just the latest evolution of doing things on other planets.
Humans could be off doing scientific discovery, and robots could be left to do some of the mundane housekeeping, the creating of the resources needed to survive.
Robots are great, but again, I think they can only tell you so much. Personally, I think we should go.
A family photo of Mars rovers reveals generations of explorers with Perseverance at the cutting edge. One day, humans might launch in their wake, and an astronaut could make the first footprint. But she might look out and see what made her footprint possible. Miles and miles of Rover.